Hey, I'm Courtney Waterman, your tutor. Lover of anime, manga, and math. And you just tuned into another session of Tutor Me Sempai. Welcome back, everyone. Today we're jumping into a 9th grade topic, creating linear equations from graphs. Now, if you're new to my channel, I'll be putting time codes in for this video in the description box below, so use that to skip ahead to whatever part of the video you think is most interesting. As always, if you have any questions about what you see today, or even your own homework, you can always put in the comment box below, or visit me on my Facebook page at Tutor Me Sempai and tell me all about it there. This video should be a rather short one, so leave a like, smash the subscribe button, and let's get started. Creating linear functions from graphs does not have to be too difficult, as long as you remember two things. The first one is your slope-intercept form. If you remember your slope-intercept form, you're halfway there. The next one is you have to find the missing components of your slope-intercept form. If you can do both of those two things, when you have a graph, you've already found everything you need in order to create your linear equation. But what if you don't remember what your slope-intercept form is? How can you figure out how to solve for the missing components if you don't even remember what it is? Well, hey, if you need to know what your slope-intercept form is, check it out. It's this. Y equals mx plus b, where m is going to be your slope and b is going to be your y-intercept. Now, if your question is, what are the two missing parts? These are those two missing parts that you are going to have to solve for whenever you have a graph. So technically, you can label this as your 2. This is your number 1, remembering your slope-intercept form, and then your number 2 is solving for your unknowns. Once you have your unknowns, plug them back into this generic formula, and then you'll have your linear equation. So we're going to do exactly that for our first example. Now, this example, we're going to actually have to zoom in on this because I don't trust myself to draw it. So we're going to take a deeper dive as we figure out both our slope and our y-intercept. So you see, for this first example, we have a graph of a linear function. However, we don't know what the equation is for this function. We do see a nice line here, so we know that this is a linear function. Remember, whenever I talk about linear functions, I'm talking about whenever you have a graph, it depicts a line. That's our working definition of a linear function. If you have no idea what I'm talking about when I refer to working definitions, I recommend you check out my first video on linear functions. You can find it right up top, and it'll tell you pretty much what you need to know about your linear functions. So check that one out and come back to this one so you don't get confused when I'm talking about linear functions and you're working with a different definition than I am. Back to the line. We have a nice line here. And remember, the goal of this is to find your two missing pieces of your slope-intercept form. Now, that's going to be your slope and your y-intercept. And I've given you a hint. The y-intercept is going to be denoted by the red dot. The red dot is where our graph here, our line, intercepts the y-axis. Now, where is that? Well, we see it's at -4 here, right? This -4 is going to be where our graph intercepts the y-axis. So that's going to be our y-intercept. Cool. First part done. Now we need to figure out what our slope is. Now, I have a suggestion whenever you're trying to find this slope. We want to remember that our slope is rise over run. Whenever you're trying to find your slope, rise over run. Now, rise is going to be how you're traveling on the y-axis. Run is going to be how you're traveling along the x-axis. So rise is going to be up and down. Run is going to be your left and right. Once you remember your rise over run, I want you to pick 2 points that you know the definitive value for. You don't want to pick a point just because it's the next one over. So let's say instead of having this point here, you had a point right here, right where my mouse cursor is. This would not be a good point to choose because you don't know what that value is. And we don't want to guesstimate anything. We want to make sure that we're very confident in the points that we choose. We don't have to worry about that for this graph, but that doesn't mean that it's not going to be a potential problem for other graphs. We want to start at a point. So I think the easiest point is going to be our y-intercept. Let's start here, and then let's go 1 point over and see, does that work? So when x is 1, what is the value of the function? -2. We clearly see that. So it's safe to use the point 1, -2, because we know that is a definite point. We're not estimating anything. Now that we have 2 points, we can use our rise over run to figure out what our slope is. Remember, rise is going to be how you're traveling on the y-axis. So we said our next point is going to be this 1, -2. We started off at 0, -4. So we traveled from -4 up to a -2 on the y-axis. How far is that? Let's see. 1, 2. So our rise is going to be 2. How about our run? Our run is going to be how we're traveling along the x-axis. So we started at 0 and we went over to 1. So we traveled 1 distance. So our rise over run is really going to be 2 over 1. And notice we went up 2 and over 1 to the right. In both cases, these are positive movements. We're going up, so we're getting more positive, right? And then we're going over to the right, so we're getting more positive. So this is going to tell us that our slope is going to be positive, which if you look at this graph, you're increasing. So it kind of makes sense. Your slope is going to be positive because your graph is increasing. So now we found our rise over run. We said it was 2 over 1, which you can simplify to just 2. And we found our y-intercept, which we found to be -4. We have both parts that we need in order to create our linear equation. Let's get back to our whiteboard so we can make our equation. So we said the slope was 2 over 1, which you can simplify to just 2. You don't have to necessarily write the 2 over 1 for your slope because anything over 1 is just itself. We said that the y-intercept was going to be a -4. And remember, you have a y equals mx plus b for your slope-intercept form. Now you can just plug in your unknowns and you have your equation. An equation means that you have to have an equal sign. So make sure you write your y, you write your equal, and then your m, or slope, is going to be what? 2. So we write 2, and it's positive. Remember, we're going up. We're positive. 2x plus, well, we have what for the y-intercept? -4. So instead of having this plus negative, we can just write the negative. -4. So our equation is going to be y equals 2x minus 4 for our graph. Let's look at another example. We're going to do the same thing for this example that we did for the previous example. We want to find our slope and we want to find our y-intercept. And we're going to plug them both in to our slope-intercept form to get our equation at the end. So let's take a close-up look of this graph. So upon taking a close look at this graph, you see I gave you another hint for our y-intercept. Now, I'm being generous. This won't necessarily be always given to you. However, understand your y-intercept is going to be where your graph intercepts the y-axis. So in this case, it's going to be a +4. So we know our y-intercept. What is our slope? Remember what I said before. We want to understand rise over run is going to help us get our slope, and we want to find 2 definitive points. No guesstimation. Unlike our first example, if we went over to 1 from 0, that's not an exact number. We don't know what that is. That could be 3.1, 3.2. We don't know. And that's not a good point to pick. How about if we go to 2? This is also not a good point. So you see, unlike our first example where we had a very clear point from our first choice, we need to keep going. 3 is also not a good point to choose. No guesstimation because we don't want to get the wrong slope because we guessed wrong. 4. 4 gives us a very definitive point. When x is 4, the function value is going to be 1. So our 2 points that we can use is going to be 0, 4 and 4, 1. Now we can figure out our rise over run. Starting with our rise, we start at 4 and you see we have to go all the way down to 1, right? So how does that look? Let's see, 1, 2, 3. We're traveling 3 down. And our rise is going to be negative now, right? Because we're going down. Negative. So this is a -3. However, we're going up the x-axis, right? We're going positive to the right. So the bottom, our run, is going to be positive. But how much is it going to be? Well, we're starting at 0. And we're going all the way to 4. So that's going to be 1, 2, 3, 4. So we have a -3 rise and a +4 run. That means our slope is going to be -3 over a positive 4. Now we figured out both parts that we need in order to find our linear equation. Let's get back to our whiteboard and make our equation. So we said the y-intercept is going to be 4 this time, a positive 4. And we said our slope is going to be a negative 3 over 4. Now we have everything we need to plug into our slope-intercept form. Remember, an equation needs to have an equals. So make sure you write your y equals. Now you could write f of x equals if you're doing a function, but we're just doing a linear equation. Y equals m, which is our negative 3 over 4, x plus a positive 4. So that means that the equation of this graph is going to be y equals negative 3 over 4x plus 4. We have now found the equation of this line. So I hope you're able to follow into the examples. I hope you see that creating your linear equations from your graph doesn't have to be too difficult. However, if you had any question about what you saw today or even your own homework, you can always put it in the comment box below or put on my Facebook page at Tutor Me Sempai and tell me all about it there. If you haven't done so already, remember to leave the like. It really helps the channel by letting YouTube know that you found this video helpful. And if you found the video helpful, so can someone else. So leave a like, smash the subscribe button, share this video with a friend, and also ring that notification bell so you know exactly when I drop my next videos. Well, that's all the time I have for today. I'm really hoping this helped with your homework, and I'm looking forward to seeing you again next week. I'm Courtney, and this is another session of Tutor Me Sempai.